Database management system. In the previous chapter, we have discussed about what is a database management system, different definitions that are associated, what are the various features of database management system, how it helps in functioning of storage, retrieval, manipulate of data set, and how the data can be utilized or queried for different purposes in the database, and the advantages and disadvantages of database management system. Objectives. In this chapter, we will discuss about the data file management, different data models in the data management system, storage of data. Data file management. The data file management system meets the needs of the user by guarantee validity of the data in the file. It minimizes the potential for lost or destroying of data. A file system provides a means to store data organized as files as well as collection of functions that can be performed on files. File system maintain a set of attributes associated with the file. Ideally, typical operations of a file system include create, delete, open, close, read, write. File organization is a logical structuring of records as determined by the way in which they are accessed. The file organization has several criteria, that is short access time, easy of upgrade, economy of storage, simple maintenance, and reliability. There are different types of data file structures present. Simple list or the pile. This is the least complicated form of file organization. The data collected is in the order they arrive. Agent. Each record consists of one burst of data. The purpose of this list is simply to accumulate the mass of data and save it, and record accesses by exhaustive search. The only advantage of this file structure is that to add new records, you simply place it behind the rest. The sequential file. It is the most common file structure which is based upon using alphabetic characteristics of fixed format is used for recording. It is a normal strategy of divide and conquer approach. As such, has begun by dividing the file in half and looking first at the item in the middle. If it exactly matches the target combination of numbers or letters, the search is done. If not, the item of interest is compared to each of its neighbor to determine whether the alphanumeric combination is lower or higher. The key field is uniquely identifies the record. It is typically used in batch applications. That is an only file organization that is easily stored on tape as well as disk. Index sequential file system. It is a file system that adds an index to a file to support random access in the database management. It is also an overflow file to the data. This file system greatly reduces the time required to access a single record in the database. There can be multiple levels of indexing using the provide greater efficiency in access. Index file. This coil system records are accessed only through their indices. The variable length of the records can be employed in this file system. Exhaustive index contains one entry for every record in the main file. They can be partial in next contains entries to the record where the field of interest exists. It is mostly used in application where timeliness information is critical. For example, airline reservation system, and inventory control system. Database models. A successive database organization is in the ability to integrate GIS with the existing internal database. Many of these databases are relational, as the relational database approach for a database management is being implemented in the most of the GIS. There are the number of database models by which GIS real world model is built. Amongst those that have been used for management of attribute data are hierarchical, common network, and relational database management system. The purpose of the data model is to provide a common computationally meaningful medium for used by system developers and users. For developers, the data model provides a means to represent the application domain. For the user, it provides a description of the structure of the system, independent of specific items of data or details of an particular implementation. A clear distinction should be made between the data models upon which the database system, like a relational model, and the semantic data model built. This can be explained by means of entity attribute relationships. The three currently most important data model approach are record based, object based, and object relational based on the entity attribute relationships. Hierarchical database model. When a data set is having many relations, then an hierarchical model is used. This hierarchical model is used in environmental science for plant and animal taxonomy, soil classification, etc. These models have easy understanding capacity and they are easy to update and expand needed. They also provide a quick and convenient means of data access and data retrieval. The disadvantage of the hierarchical database model is that large index files have to be maintained and certain attribute values may have to be repeated many times, leading to a data redundancy which increases the storage and access cost. Many GIS database have, in addition to one-on-one and one-to-many relationships, many-to-many relationships in which a single entity may have many attributes and each attribute is linked explicitly to many entities. The structure allows user to move from data to data item through a series of pointers. The pointer indicates the relation among the data items. Advantages of hierarchical model. This model promotes data sharing and also promotes conceptual simplicity and data integrity. The hierarchical model provides database security and enforced by database management system. This hierarchical model is efficient with one-to-many relationships of database. Disadvantages. This model requires not a job physical data storage characteristics. The navigational system requires knowledge of the hierarchical path. If there is a change in the program structure, then there should be change in the database. This model lacks standards and doesn't define data and implementation limitations. Network system. When a data system is having a data structure which is more rapid linkages is required with graphical representation, that is to identify the items in a map or a figure need to be linked together, even though the actual data about their coordinates may be written in very different parts of the database. In such requirement, network system is used. These network systems are very much useful in representing relationships and linkages of data. They avoid data redundancy and make good use of available data. The disadvantages of the network system is that enlarged overhead of the pointers, which is complex system, and it become quite a substantial part of the database system. Network systems are generally considered to be an improvement over the hierarchical structure for GIS work because they are less rigid and can handle many to many relationships. Also, unlike the hierarchical structure, they reduce the redundancy of data like coordinate pairs. The major drawback is that in very complex database, the number of pointers can get quite large, coming to comprise a substantial portion of the storage space, and this can be avoided by using different data structure such as the relation database structure. Advantages. Network model has conceptual simplicity. This model handles more relationship types data. There is a flexibility for data access in this model. Data integrity is promoted with conformance to standards. This model includes data definition language and data manipulation language. Disadvantages. The efficiency of this model is limited by the model complexity. The navigation system yields complex implementation, application development and management. Structural changes required. Relation database model. The relation model uses a collection of tables to represent both data and relationships among those data. Each table has multiple columns. Each column has a unique name. The data is arranged in relation which is visually represented in a two-dimensional table. The data is inserted into the table in the form of tuple. A tuple is formed by one or more than one attributes, which are used as basic building blocks in the formation of various expressions that are used to derive a meaningful information. There can be any number of tuples in the table, but all tuples contain fixed and same attributes with varying values. The relation model is implemented in database where the relation is represented by a table. A tuple is represented by a row. Common attribute is represented by a column of the table. Attribute name is in the name of the column, such as identifier, common name, city, etc. Attribute value contains the value for column in the row. Constraints are applied to the table and form the logical schema. In order to facilitate the selection of a particular row from a table, the attribute, that is the column names, are used, and to express it, the selection of the row, some fields are defined uniquely to use them as indices. This helps in searching the required data as fast as possible. All the relational algebra operations can also be performed on the relational database model. Operations on the relational database model are facilitated with the help of different conditional expressions, various key attributes, predefined constraints, etc. Advantages. This model uses independent table. There is a structural independency is promoted. The table or view improves the conceptual simplicity. The user are not having the physical level detail for obtaining an information. The query capability is based on SQL system. This model improves implementation and management simplicity. Disadvantages. This model requires substantial hardware and software systems. The conceptual simplicity gives the untrained people the tools to use a good system poorly. This model may promote information problems. Data language. Database management system provides a data-defined language to specify the data with a schema and data manipulation language to express database queries, any updates. In practice, the data definition and data manipulation language are not separate but common languages. Instead, they simply form parts of a single database language such as widely used SQL language. Ability of standard query language is one of the advantages of the relational database model. Additionally, the model has a sound theoretical basis in mathematics and a simple logical data model that is easy to understand. The relational database model is also easy to understand. The database model is more flexible than either of the previously used hierarchical or network models. However, the model will always produce some data redundancy and can be slow and difficult to implement. There are also problems with handling of complex objects such as those found in GIS, as there is a limited range of data types and difficulties with this handling of time. Storage of GIS data. GIS should provide storage space for both spatial and attribute data. Products either individually or separately, and the design of this kind of system is in such that these data products are retrieved as and when the analyst needs further analysis. In addition, the GIS should have the capability of linking the spatial as well as attributes through software in order to establish that topology. There are three different files to be created for any GIS project: topological data file, coordinate file, and file with attribute data. There are two different approaches in storing of the data, that is the hybrid data model and integrate data model. The benefits of using an integrated architecture are considerably allowing a uniform treatment of all data by database management system and does not consigning the spatial data to a less sheltered existence outside the database, where integrity, concurrence and security may not be so rigorously enforced. The hybrid data model. This type of data storage mechanism is used for locational information but not suitable for attribute or thematic information. In this model, the GIS software links the cartographic files and the database management system during different map processing operations such as overlay. Nowadays, there is a clear trend of establishment to provide access to multiple database management system with vendor of GIS software and other developing generic relational database management interface. In this type of data model, the topological data and the coordinate data stored in a single file system and the corresponding attribute table data are stored in the another file system. These two data files can be linked or hybridized by means of a software linking mechanism. Linking is performed by storing identification codes as column data, that is primary key in the attribute database. The integrated data model. This is the second type of GIS data model which is more integrated with the database management system than the hybrid system. This data model approach is also called as spatial database management system approach, as the GIS will be serving the query processor sitting on the top of the database itself. In this model, a number of implications in terms of spatial characteristics of spatial data. In this model, both coordinates and topological information are stored in the form of coordinate pairs for individual vertices along line segment in different rows in a database table. Handling of large spatial database is the need to convert to the coordinate information into one-day spatial keys that can be stored as database table columns. These can be indexed in the normal way and used for fast retrieval of map elements contained within or overlapping of specific geographical search area. Model: there are two ways of storing the coordinate information as relational tables. In one way, the coordinate pairs and the polygon terminator and vertices is stored as individual elements or rows in a database. It is very difficult to search any element because each element must be recomposed from its format to whole polygons or group of polygons. Object-based database model. This data model is an extension of the integrated data model where the SQL language functions are included in the final analysis. In integrated model, it is not sufficient merely to hold data on the map elements in a database, and for GIS purpose, the operations to be performed on these elements speeded. This led to the object oriented approach in spatial data handling. In this model, each entity is represented by values of local variables and a set of operations or methods that can operate on the object. The intergraph 𝗳/𝗧 system operates on the object oriented approach. The object based data model for GIS purpose are based on entities, attributes and the relation between the entities and attributes with respect to the location, the temporal changes and both location and time. Organizing strategy of database management system. The storage of non-spatial attribute data is a well-established technology quite apart from GIS. In its simplest form, it is an analog to the filling system. The information to be extracted from the database via some organizational structure. The traditional filling cabinet imposes an alphabetical structure on the data, allowing us to retrieve many pieces of related information from a record card indexed by alphabetic name. In contrast, the computer-based database management system allows us to extract information not only by name but also according to a selection of other pieces of information in each record. There are a range of organization strategies for database management system packages, each of which imposes different models on the data, affecting the ways in which it can be extracted. The most popular structure for recent GIS software design has been the relation model, which consists a series of tables linked by key fields, which allows the establishment of relations between the entities in different tables and impose no navigational constraint on the user, whereas hierarchical structure, for example, embody rigid relationships between the objects in the database, the relational system, all of the establishment of temporary links between the tables sharing common fields. This serves to reduce redundancy and makes the database more flexible. The key fields in the geographic relation database management system are typically the unique identifiers of the point, common align and area objects to which the attribute data in the table is related. Summary. In this chapter, we understood about how the data is stored in the database management system in the form of file structure, different data models that are present and their advantages and disadvantages, and how GIS data stored in the database management system. Through the database management system, the problems that occurred in the traditional approach to database management has been solved, as the data can be structured and represented features from the real world, and the relationships between them are clearly stated. Past traditional models may not represent these relationships, so a database approach is needed. Database management system provides the necessary requirements in the GIS technology.